So far, we've used Cartesian coordinates, which of course are my favorite coordinates after all. But we do need to learn how to use both cylindrical and spherical coordinates. We start with Fourier's law that Q double prime equals minus K times the gradient of temperature. And we can express this now in cylindrical coordinates. This can be done pretty easily just by looking up del in cylindrical and spherical coordinates on Wikipedia and scrolling down to the section on del formula. This is where I go in order to convert this general statement of Fourier's law up top into these three statements: a flux in the r direction, a flux in the phi direction, and a flux in the z direction. You'll see here that the fluxes in the r and z directions look the same as they did in Cartesian coordinates, while the flux in the phi direction, this angular quantity, looks different. It has a factor of 1 over r. We can do the same thing for the heat diffusion equation. We have first the very general statement of the heat diffusion equation, and we can take this now and using what is shown on Wikipedia, this page on del in cylindrical and spherical coordinates, we can use that to now expand this out so that we can see all the nuances of the cylindrical situation with clarity. The term in the z direction looks about the same as it did in Cartesian coordinates, while the terms in the r and phi direction now have these factors of r and 1 over r and 1 over r squared appearing. So you can see some clear differences here between the Cartesian case and the cylindrical coordinates case. This is the equation you will start with for problems involving cylindrical coordinates. We can do the exact same thing for spherical coordinates. Start with Fourier's law, the general statement, go to this Wikipedia page, and thereby transform this into QR double prime, Q theta double prime, and Q phi double prime. And now we can also expand out the heat diffusion equation shown here. First, the general statement, and then fully expand it out. You can see explicitly in spherical coordinates how this equation is different than what we had before in Cartesian coordinates. This is where you'll start for problems involving spherical coordinates.